So in this problem, we're given. So recall we're in 3 dimensions, so couples will have I, J, K components. They tell us the magnitude of that couple, I'll call C, is 50 Newton meters. So we're asked to find the value of F that will make this true. I guess we're also given a diagram. So if we apply F in the direction shown, what F will result in the magnitude of the net couple being 50 Newton meters. So we're given a coordinate system, which I'll stay with. So I'm going to call this point A, where we're applying the force downward. And I'm going to call B, where we're applying the upward force, at least with respect to the z-axis. So B is located at 300, 800, 0 millimeters. And A is located at 200, 300. So we have the setup here. This F is up, this F is down. We have our coordinate system and the points where we're applying this. So in 3D, we want to use the vector approach, so a couple is going to be an R cross F. So we don't want to confuse this for a moment about a point. It is a similar idea, but we want to be careful in which F we're using and how we're using, which R we're using and how we're representing F. We want components for each of these. So we're going to use, so this is generically the equation we want. We have our option now of, are we going to choose the R that goes from A to B, or the R that goes from B to A. Either one is okay, but which one we pick influences which force we use, or vice versa. So we need to know this distance here. So the idea will be, we can calculate this, if we use R from A to B, then we're using the force that's acting at B. In which case, that is going to be F in the positive K direction, which will look like this. This is the magnitude, and then that's the direction. Or we could use RBA, but now we have to use the force that acts at point A. In which case, here you see F is down. So this is going to be a different vector. This will be negative F in the K direction, since it points in the negative Z direction. We'll get the same answer either way, but we want to make sure that wherever it ends, we're using the force at that point to do. So here we'd use Fk, negative Fk. So I want to go, since one of my forces acts at A and one acts at B, I have to use the position vector either A to B or B to A for the couple. So it's a little bit different than what we saw last week with force about point, where it was the point we want to know the moment about to where the force is being applied. Here it's where one force acts and where the other force acts. So it's up to us, whichever we want to use, as long as this matches that or that matches that. So for the sake of my notes, I used the first one. Again, you'll get the same answer either way. So going through this cross product, this will be in millimeters, this in newtons. What should the second line be if I'm going to use RAB for this problem? The K will be 0, so it's endpoint minus start point 0 minus 0. All right, so distance vector, just as we've been doing. So we're ending at B in this case, starting at A. So 300 minus 200, 800 minus 300, 0 minus 0, and we're measuring right now in millimeters. And then what will the third line be? Yeah. Right, so this one's easy. We don't know its magnitude, but we do know it's entirely in the k direction. So I'll leave it to you if you want to go through the steps to expand this, but when we expand this, it will have an unknown value in it. It will have that f, and that's okay. It's going to be 500f in the I direction minus 100f in the j direction. And again, this will be in newtons times millimeters. So where do we go from this step? Well, we know that the magnitude of the couple, our goal is for the magnitude of the couple to be 50 Newton meters. So there's going to be a step in between. We can't set this equal to 50 because this is a vector and that's a scalar.
Take the norm and set it equal to 50?
Right, so the magnitude or the norm of this will be 50. This thing itself is not equal to 50. So we want to go up here. So we can find its magnitude is going to be 500 squared f squared plus 100 squared f squared. So the magnitude of this vector is 510f. So remember, when you're squaring the components, this is a product, you're squaring each part of it. So 500 squared f squared plus 100 squared f squared reduces down to a nice 510f. So this magnitude we know, 510f, that is equal to the 50. Yeah. Now here we want to be careful for one more thing. What do we have to do before I equate this to something? Right, this is in Newton millimeters. This was given to me in Newton meters. So for metric, it happens less frequently that you have these two different systems of measurement. Here we do have to convert everything to the same, either both Newton millimeters or both Newton meters. More commonly in English problems, this might be given to you in pound feet, and we did all of our calculations in inch pounds, in which case we again have to choose one or the other. So I'm going to keep it in Newton millimeters because that's already set here. So instead of 50 Newton meters, it'll be 50,000 Newton millimeters on the right-hand side. So now in this equation, the last thing I need to find is F. So solving for F, the force required to have that net, the magnitude of the couple be 50 Newton meters, is 98 newtons.